if we have a triangle on a surface with zero curvature, we may be interested in finding a relationship between the interior angles of the triangle. So if I label these angles 1, 2, and 3, the way we can find a relationship between these three angles is by using what we've learned about parallel lines. If I add in a parallel line that runs through one of the vertices of the triangle and runs parallel to one of the sides, so I'm going to draw a line that runs parallel to the side that connects angles 1 and 3 through the vertex that generates angle 2, I will then form two new angles, and we'll call those 4 and 5. What we know is that that line and those three angles that are associated with that line, by the way, this runs parallel, so let's mark that off, form a straight angle. And we know the straight angle adds up to 180 degrees. So we can say the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 is equal to 180 degrees. But with the introduction of that line that runs parallel to the side connecting angle 1 and 3, we also know that the side connecting angle 1 and 2 serves as a transversal as well as the side connecting angle 2 and 3. So with transversals and parallel lines, we also know special angle relationships in the case that 1 and 4 are congruent because they're alternate interior angles, and the same with 3 and 5. So additionally, we can say the measure of angle 4 should equal the measure of angle 1, and the measure of angle 5 should equal the measure of angle 3. And through substitution into the equation that relates the three angles that form a straight angle, we can find out that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 should equal 180 degrees. So we know that the interior angles of a triangle, no matter what type of triangle I'm dealing with, should add up to 180 degrees, assuming we are on a surface with zero curvature. And this is an important theorem because then we can generate some other ideas and relationships that may come into play when we're trying to solve problems that relate to angles in a triangle. One of them would be, what's the relationship between the acute angles in a right triangle? Well, knowing that the measure of angle 1 plus the measure of angle 2 plus that 90-degree angle should sum to 180 degrees, then just manipulating this equation, we can find out that the measure of angle 1 plus the measure of angle 2 should equal 90 degrees if I subtract 90 degrees from both sides. So from this fact, we can determine that the acute angles are complementary. So these two angles are acute angles, and therefore equaling 90 degrees implies that they are complementary. So just knowing that the sum of the interior angles of a triangle add up to 180, we just now brought in a new case, or a new fact that we are now aware of, that the acute angles of a right triangle are complementary. In addition to that, if we have a triangle and we extend one of the sides so that we form an exterior angle, the exterior angle would be the angle on the exterior of the triangle, whereas the interior angles are on the inside. Is there a relationship between those interior angles and that exterior angle? Well, what do we know? We know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. That's what we started the video with. We also know that this exterior angle is formed by extending that side. So 3 and 4 form a linear pair, and we know that linear pairs are supplementary. Now from here, we can see that both of these equations equal 180 degrees. So by a transitive property, I can set them equal to each other. Now I have a measure of angle 3 on both sides, so subtracting it from both sides will reveal that the measure of angle 1 plus the measure of angle 2 should equal the measure of angle 4. Now, what's special about 1 and 2 and its relationship to 4? we refer to 1 and 2 as the remote interior angles. So that term is in reference to the two angles on the inside of the triangle that do not form a linear pair with the exterior angle. So these are remote interior. If I were to extend out another side, so it doesn't have to just be that one example of an exterior angle, there are multiple exterior angles that can be formed. If I call that angle 5, well, now 1 and 3 become the remote interior angles to angle 5. So I could say in that case, now that we've derived the fact that an exterior angle should equal the sum of the remote interior angles, if I extend another side, I can draw the relationship that 1 plus 3 should equal the measure of angle 5. So those are the things you want to look out for when you're dealing with remote interior angles and exterior angles. And a third thing that comes into play, so we've done acute angles in a right triangle, we've done the relationship with exterior angles and interior angles, and now if I have two triangles where it's been established that two pairs of angles are congruent, so let's call this 1, 2, 3, and 4, 5, and 6. Well, we already know. So again, all of these things that we're deriving are based around the fact that the sum of the interior angles of a triangle is 180 degrees. So I can start with this. And if we know that 1 is congruent to 4, and 2 is congruent to 5, well then through substitution, I can come up with this new equation, or actually what I should do, not substitution, but rather, well, it could be thought of as a substitution, but both of these equations equal 180, so let's set them equal to each other. And if 1 and 4 are the same, and 2 and 5 are the same, then subtracting 1 from both sides will cancel out 1 and 4. Subtracting 2 from both sides will cancel out 2 and 5. And what I'm left with, and what I discover, is that 3 has to be equal to 6. That is the idea of third angles theorem, meaning you already know two pairs of corresponding angles are congruent. And knowing that the sum of the interior angles is 180 degrees, it must be true that the third pairing is congruent. So those are the relationships between interior, exterior angles, the sum of the interior angles, acute angles in a right triangle, and the idea of a third angles congruency, given that two congruent pairs already exist.